Welcome to EDU World Space.
So we have 2-point masses. I'm going to make this one, red. Whoops. Let's try to make it red. There we go. And I'll make this one blue. Okay, the red one is 200 kilograms. And the blue one is 500 kilograms. And they're separated by 4 meters. If you placed another object that is 50 kilograms halfway between them, then what is the net force exerted on that object? Well, notice that the blue object is exerting a force in that direction, and the red object is exerting a force in this direction. Now, the force exerted by the red object is smaller because it has less mass. So there are 2 forces. I'm going to write force red is G M red M green over R squared. But here, since it's halfway, R is 2. And then the force for the blue one is G M blue M green over R squared also. The net force will be in the direction of the blue one. So force net is G M blue M green over R squared minus G M red M green over R squared. We can factor out G M green and R squared, and that just leaves us with MB minus MR. I'm going to substitute those into the equations using a calculator. So it's going to give me 6.67 times 10 to the negative 11th power times mass green, which is 50, over R squared, R is 2, squared, times MB minus MR. MB is 500, MR is 200, 500 minus 200. And that gives me, looking as if we've got 3 significant digits here. So it is, where's my calculator? 2.50 times 10 to the negative 7th power. Newtons toward the more massive object. OBJECT. Okay, so now in part B, we don't know the position. And so we've got the red object and we've got the blue object. The green object is going to go in between, and it's going to be actually closer to the red, less massive object than it is to the blue object. This is going to give a net force of 0 if we put it in just the right place. So our red is going to be one number, and I'll just set an RB. So this is the radius to the red one. RB is going to be another number, but it's going to be 4.00 minus R red. Because if we add this distance plus this distance, we will get the total distance. Didn't have to erase everything there. Okay, I should write my masses. 250 and 500, all in kilograms. All right, so now the net force is going to be, let's do the red one. No, we did the blue one first last time. Let's do the blue one. G, M blue, M green over the blue radius, which is going to be 4 minus that squared plus G M red, and I didn't mean to write plus, meant to write minus, because they're in opposite directions, mg over r red squared. It's supposed to be a red down there. Okay, and that needs to equal 0. If that equals 0, well, then the g's cancel out. The mg's also cancel out. And so it simplifies to mb over 4 minus r, and I'm just going to say that r is the same as rr. 4 minus r squared minus mr over r squared, mbmr. All right, we need to figure out what r is. So I'm just making sure I didn't make any mistakes yet. There are a couple of ways to do this, but I'm going to do it what I think is the easiest way, which is I'm going to graph this and figure out where it crosses the x-axis. So MB is 500. I'm just going to write y equals 500 over 4 minus r. I'm going to put x in there, squared, and then minus 200 over x squared. And I see that this crosses the x-axis at 1.55. So again, I just put into a calculator y equals 500 over 4 minus x squared, 200 over x squared, and I looked for the root, which is where it crosses the x-axis, and it crosses the x-axis at 1.55. And this is in meters. So R sub R is 1.55 meters. It also crosses the x-axis at negative 6.883, but we're looking for a positive answer because it needs to be between the two. So our answer then is 1.55 meters away from the 200 kilogram object.